Hello, in this video we present ROM programming. Programming of the ROM, when we look at the hardware procedure that programs the ROM, this procedure, it blows fuse links, and every zero in the truth table of the ROM, it specifies the absence of a connection, which means the fuse is blown. On the contrary, every one in the truth table specifies a path that is obtained by a connection, which means the fuse remain connecting two points with each other. Programming the ROM, we can look at a specific example now. If we look at the truth table below, now programming the ROM will result in the configuration that we see on the next slide. As an example, the table specifies the following: 10110010 for permanent storage at address 3. So this is address 3 right here, and this is the information that is stored or should be stored in this ROM location. Now, there are 4 ones here, which is this one in A7, A5, A4, and A1, and there are 4 zeros at locations A6, A3, A2, and A0. The 4 ones in the word are marked with X next, as we will see it. It denotes temporary connection in a place of a dot that is used for permanent connection in the logic diagrams, and the 4 0 on the word are programmed by blowing the fuse links between output 3 of the decoder and inputs of the OR gates associated with A6, A3, A2, A0, which have zeros in these locations as we have just mentioned. We will look next at the hardware that shows us this. So this is the hardware. If we look now, the example that we took, it is 5 by 32 memory, which means 5 by 32 decoder, which means it has 5 inputs, I4, I3, I2, I1, I0, and it will have 32 outputs, one output for each word. And this memory is 32 words by 8 bits per word. Now, the fuses, as we have just mentioned, there is one here, so this is temporary connection, and one here, and one here, and one here. So these fuses will remain connected, and the other fuses at the zeros, these will be blown. So when the input of the ROM is 00011, which means the input is a 300011, so this is 1, this is 1, and all others are zeros. These are the outputs of the decoder. So all outputs of the decoders are 0, except for the output 3, which is at logic 1, as we have just mentioned. The signal equivalent to logic 1 at decoder output 3 propagates through the connections to the OR gate outputs of A7, A5, A4, A1, which is the following. There is connection here, so this one will come here, so this will be 1 here, and this one will also come here, so this will be 1, and it will come here, so this will be 1, and it will come here, so this will be 1. The others, this will be 0 here, so that will be 0, and 0, and 0, and 0. Therefore, the 8 OR gates will produce the following: 1, 0, 1, 1, 0, 0, 1, 0, which is the word stored in the memory as we have just seen in that truth table. Don't forget that these lines of the decoders are zeros. Therefore, this will be 0, and this will be 0, and this is 0, 0, 0, 0, 0. Therefore, this OR gate has only 1, 1 coming from this line here, and it will have 31 zeros coming to it. So that's why the output is 1. The other OR gate, it has all 32 inputs are zeros. Therefore, the output is 0. Now, if we look at the ways to program the ROM, there are different ways to program the ROM. The first is we call mask programming. And mask programming, it is done by the semiconductor company during the fabrication. So the company is given for each word what is to be stored 1 and what is to be stored 0, and it will do this at manufacturing, and this mask programming, the ROM, will never be changed. Any bit that needs to be changed, the whole ROM will need to be thrown away. The second way is called programmable read-only memory. So this is different, and the abbreviation is PROM, which is very popular, very famous abbreviation actually. In the PROM now, when it's ordered, the PROM unit contains all fuses intact, so all fuses are connected, giving ones in all the bits of the stored word. And the fuses in the PROM are blown by application of high voltage pulse to the device through a special pin. This procedure allows the user to program the PROM, that's what's called programmable ROM, in the laboratory. PROM programmers are available commercially. They can be bought from the market in order to facilitate the procedure. And the hardware procedure for programming ROMs or PROMs is irreversible. So once you blown the fuse cannot come back to be connected. It is done once and forever. So the main difference between the mask programming and the programmable ROM, this is done at the factory and it never changes. This is done, the second one is done in the laboratory at the user. Again, once it is done, it cannot be changed. Now the ROM one is called erasable PROM or EEPROM. Erasable PROM, it can be restructured to the initial state even though it has been programmed previously. So that's why it's called erasable, because you can erase what you have programmed. So when the EEPROM is placed under special ultraviolet light for a given length of time, the shortwave radiation discharges the internal floating gates that serve as the programmed connections. After erasure, the EEPROM returns to the initial state and can be reprogrammed to a new set of values. This is a very useful read-only memory because it can be programmed and erased. So it can be used multiple of times. It can be used many times, especially in development. When someone is trying experiments in the laboratory, he wants to try a PROM, so he can program it and then change it as he or she wishes. Finally, the last one is called electrically erasable PROM, or EEPROM, or sometimes E-squared PROM. It is like the EEPROM, except that the previously programmed connections can be erased with an electrical signal instead of the ultraviolet light. So these two are erasable. One is by light and one by electricity. The flash memory devices that we use often, very popular now, are similar to EEPROMs, but they have additional circuits so that they can be used multiple of times, many times.